Dear students, in today's class, we are going to focus on solving additional problems from different reference books. So here I have taken S. Chan, R.D. Sharma and Oswal, 3 books. And from these 3 books, important questions will be selected and same thing will be solved on the board. So as you all know that the chapter real number has already been completed related to NCERT problems. So let's focus on additional problems. Please do write today's date. It is 24/5/2021. Now write side heading additional problems. Additional problems. In bracket you may write S. Chance, R.D. Sharma and Oswald. From these 3 publications, I have selected some questions which have already appeared in the previous year examinations, and even some may ask in the forthcoming examination also. So within 2 days, we will finish up the solving additional problems. Okay, let me go for taking the first problem. You all know that HCF of 2 numbers can be found out by Euclid's division algorithm. Even this can also be extended to 3 positive integers. One such problem was given in the examination. So let me give you the same. That is, we will find the HCF of 3 numbers by Euclid's division algorithm. Yeah, please do copy. Now I'm going to take very simple problem. Right. First one. The first time, this is find the HCF of 40, 36 and 126 by Euclid's division algorithm, or else Euclid's division lemma. Let's find out. Yes. Solution. Please go on writing with me. You all know that how to find out HCF of 2 positive integers. Let's use the same. First, I'll go for taking 40 and 36. Let us find out the HCF of these 2 numbers, and whatever the HCF we will get, that number and 126. Then we have to find out HCF of these 2 numbers. Right. First, I'll take 40 and 36. You all know that 40 is greater than 36 by Euclid's division algorithm or lemma. Start expressing that the given numbers in the form A equal to BQ plus R. As these numbers are very simple, let us write it directly. 40 and dividing 40 by 36, you will get 4 as the remainder. And it can be done as 40 is equal to 36 ones are 36 plus 4 is the remainder. And this process should be continued till we get the remainder as 0. Here is remainder 4 and 36 is greater than 4. Start dividing 36 by 4. 4 9s are 36. Now we got remainder as 0. Hence, the divisor will be HCF. HCF is 4. HCF of only these 2 numbers. Right. HCF of 40 and 36 is, this is 4. Now, let us find out the HCF of this 4 and the remaining number. Remaining number is 126. Right. It is, you all know that 126 is greater than 4. Use the Euclid's division algorithm. Then final 126 can be written as 4 3s are 1s are, right, plus 2. If you do not know how to express it directly, you can go for using working count. So divide 126 by 4. See, 4 3s are 12, 0 will remain. Then carry down 6, 4 1s are 4, 2 will remain. We have written the same. Next, here is the remainder is not equal to 0. Therefore, continue to divide. So 4 is greater than 2. 4 can be written as 2. 2s are 4 plus remainder is 0. The divisor 2 will be HCF. Now here I write HCF of 126 and 4 is 2. And this will also be the HCF of the given numbers. And write the conclusion, final conclusion as HCF of the numbers 40, 36 and 126 is 2. Hope that you have written. It should be written in the notes only. No need to go for using separate notebooks or sheets for solving additional problems. It should be in the notebook. Okay. Now, let me give you same time only for practicing. It should be done in your home. Right. Another one, second one. Same type question. Find the HCF of. Find the HCF of, right, 144, 180 and 190 by Euclid's division algorithm. It is home assignment. In your notebook only, just leave one page for this. Now you don't go for solving it. After class only, you can solve it. Now we'll move on to the next type problem. So I'll rub it. Shall I rub this? Yes.
Sir, unmute your audio. Raju sir, unmute your audio.
Now, let me take third problem. It is the second type. And this was also given in the examination. I'll give you that. Right. Find the HCF of 65 and 170. Also, express it in the form 65m plus 170n. Full stop. Hence, find m and n. Please go through this once. Go through the given statement. It is find the HCF of 65 and 170. Also, it should be expressed in the form of 65m plus 170n. Then after that, whatever the number will be there in place of m and number will be there in place of n, those will be the values of m and n. So it is important type. So let's go for finding. Right. You know that how to find out the HCF by Euclid's division algorithm. Of course, you can find out HCF by fundamental theorem of arithmetic also. But if you want to express that HCF in this form, you need to find out HCF by Euclid's division algorithm. Right? Here, the given numbers are 117 and 65. You know that 170 is greater than 60. Please go on writing with me. By Euclid's division algorithm, 170 can be written as 65 ones up, right? Plus, then how much will remain? See, 65 is there. Subtract 165 from 170, 35, 45, 52, right? If you are not able to write it directly, again, as I said, you may go for using working column for division. 170 on dividing this by 65. 65 ones are 65. Here 7 minus 5 is 2. 11 minus 6 is 5. 52. Remainder is not equal to 0. Let's continue. 65 is greater than 50. Even this can also be written directly. 65 is equal to 52 ones up. Plus, see that you will get 13, right? Next, remainder 13, which is not equal to 0. Continue to divide. So 52 on dividing this by 13, 13 fours up, right? Plus 0. Then what is the HCF? HCF will be
13, sir.
very good. So here I'm right. Therefore, HCF for 170 and 65 is 13. So in the given question, we have 3 sub questions. Now we have answered for first sub question. Yes. Go through it. Next, let's focus on second sub question. Also, express it that HCF should be expressed in the form 65m plus 117n. Let me tell you that first you write the first step. You all know that HCF is 30. It should be written in this form. Okay. Observe the board. Here is 30. Observe whether 13 is there in the remainder. It is here. This whole statement should be used for expressing. Just look at the board, don't copy. We have 65 equal to 52 1 plus 13. Now 13 should be solved. If you want to solve 13, it should be transferred to the denominator, left hand side. 65 minus 52 ones up. Hope that you have understood this. Have you understood?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
13 should be solved so that we have transferred 52 into 1 to the left hand side. Now, here I write 13 is equal to 6. Please write with me. 65 minus 52 ones up. Written up. Now look at it. See, it should be expressed in the form 65m plus 117n. We have got 65. We need 117. Hence, we need to take substitution for 52. Here, I'll write 65 as it is. As I said, we need to take substitution for 52. Into 1 is there, I'll write it. Have you understood?
Yes, sir.
Okay.
Yes, sir.
Now, let us solve 52 from the given statement. Observe in which step the remainder 52 is there. In the first step only. Please do follow. Whenever I go for writing, in that time only it should be copied. 52 is in the first step. Let us solve. On solving 52, you get 170 minus 65 ones up. Got it?
Yes, sir.
Yes, sir.
Yes, sir.
52 should be solved. Write this as it is. Transfer 65 into 1 to the left hand side. Then it will be 17 minus 65 ones up. Here I'll write the same. 17 minus 65 ones up.
Sir,
Sir, 117, sir.
Yes?
117,
sir.
sir.
It is 117. Sir.
Ah, very good. This is 170. 170 minus 65 ones up. Have you copied this?
Yes, sir.
Yes, sir.
Now see that in this statement, we have both 65 and 170. Let's go for simplifying to express in that form. Here I write 65 as it is. Outside the bracket, 1 is there. Do remember that. Now 117 ones are 117. Here minus sign is there. So minus 117 one times. Now, again look at the word. Minus into minus plus. Observe it. Here 65 1 times. Outside the bracket 1 is there. 1 into 1. 1 only. Hence we can write 65 1 time. Now this is equal. Observe it. Here don't go for adding 65 and the 65. Instead, you have to write how many times 65 is there, because it should be written in that form. 65 here 1 time, 65 here 1 time, total 2 times, 65 2 times. Next, here 117 1 times is there. Here we want plus 117. Hence, here I write plus 117. Let me take minus inside the bracket. Got it? Now see that 65 2 times plus 170 minus 1 times is of the form 65 m plus 170 n. So it is expressed in that form, is of the form like this. So we have answered for second sub question. Now let us find out the values of m and n. Here are right. See, what is there in place of m?
2, sir.
2.
2. In place of n?
Minus 1.
Minus
So therefore, m is equal to 2 and n is equal to minus 1. Is it not easy? Is it not easy?
Yes, sir.
Yes, sir.
Easy.
So it was given in the examination for 2 marks.
Okay.
Excuse
Let
me,
us
sir.
taking the next problem. It is also like this only.
Excuse me, sir.
And even this was also given in the examination. I'm going to take the same, right?
Excuse me, sir.
Yes.
Sir, you can once again explain, sir.
Okay. Just look here. You all
Sir,
know
you
that.
can once again.
I'm going to explain it again. Observing. We have found out HCF. Then it should be written in this form, 65M plus 117N. We have written the same. Here 13 is there. You have to observe in which step the 13 is there as remainder. It is in the second step. Solve 13 from that step. See, 13 is to be kept as it is. Transfer 55 into 52 one time to the left hand side. Then 65 minus 52 one time. Next 65 should be written as it is because it is already there. Then we want substitution for 52. And 52 as a remainder, it is in the first step. Solve that. 52 is equal to 170 minus 65 one time. So here minus sign as it is. In place of 50, we have written 170 minus 65 one time. And into one time is there that has been written outside the bracket. Then in the next step, 65 as it is minus 170 as it is. But don't forget to multiply this. Here one time. Next minus into minus plus 65. Here one time is there. Outside the bracket one time. 1 into 1 time only. Next here 65 one time. 65 one time. Total 2 times. Next minus 117 into 1 is there. But we want plus 117. Hence, I have written plus 170 as it is. This minus is taken inside the bracket. It will not affect the given state. Now, this is of the form 65M plus 117N. So, M in place of M, 2 is there. Therefore, its value is 2. In place of N, minus 1 is there. Therefore, its value is minus 1. Shall I take up next one?
Yes, sir.
Yes,
Okay.
sir. Sir.
This was all.
Yes, sir.
In additional problems, what all the problems I'm going to give you, all are important. So you don't need to put star mark. Just it is understood. Additional problems are important only. Right. Fourth question. Express the HCF form. Express the HCF of 81 and 237 of the form 81x plus, sorry, it has been given like 237x plus 81y. Also find the value of x square plus y square plus xy. This is the statement they have given. Now, let's go for finding. Here also you can observe that there are three sub-questions. One is you have to find out the HCF of the given numbers. Second one is that HCF should be written in this form. 237x plus 81y. After that, you should find out the values of x and y. Those should be substituted in this state. Don't be hurry when the teacher is giving the information. Your attention should be only on our information. Yes. Now you may start finding the HCF. As you are very familiar, please go for finding. Right. Solution. The given two numbers are 237 and 81. 237 is greater than 81. You know, by Euclid's division algorithm. You may write it directly, or else you may go for dividing that. 237 is there, and dividing this by 81, it will be 2s. 81 2s are 162. Here 1 will remain, then 13 minus 6 is 7. 71 will remain. Right. 237 is equal to 81 2s are plus 70. Remainder is not equal to 0. Continue. 81 is greater than 71. It can be written directly as 81 is equal to 71 ones are plus 10. Have you written the same?
Yes, sir.
Okay. Now,
Sir,
again,
81
remember,
is 162, sir.
Minus 2 is equal to 5, sir.
yes. Somebody is telling 2 equal to 5, something, no?
237 minus 160 is equal to what? 75, sir.
Oh, sorry, sir. Okay. 75. 7 minus 2 is 75. Now, correct. 75. Now, 81 is equal to 75 ones, then you will get 6. Then, remainder is not equal to 0. Then 75 is equal to 6. Ones are 6. 1 will remain 15. 6 twos are 12 plus 3. Have you got same?
Yes, sir.
Yes, sir.
Okay. Next. Again, remainder is not equal to 0. Let us express 6 as 6 is equal to 3 twos are plus remainder will be 0. Then what is the HCF?
3, sir.
3.
HCF is 3. This is the divisor. Right. Conclusion. Therefore, HCF of 237 and 81 is 3. Next. Let us express that in the form 237x plus 81y. Start writing with it. Here, HCF just we have found out. This is 3. Observe in which step 3 is there as remainder.
75.
Third step, sir.
In third step.
First step. So here it is. Let us solve 3. It is 75 minus 6 into 12. Have you written the same?
Yes, sir.
Okay. Next. Now, here we have 75 and 6. See that? But in the statement we want 237 and 81. Hence, we need to take substitution for both. 75. 75 is in first step. Let us solve that. First observe. When I'll be writing, you can also copy. 75 is there. It is 237 minus 81 twos. Right. 237 minus 81 twos. Minus. Observe this carefully. Here 6 into 12 is there. We need to take substitution for 6. So I left the space and 12 has been written outside the bracket. Now, let us solve 6. It is in second step. 6 can be written as 81 minus 75 ones up. Right. 81 minus 75 ones up. See. Here I have used common brackets as well as square brackets. As we have one more term is there outside the bracket. Next, this is equal to here 237. I'll write it as this 80 minus 81 2 times as it is. Now look at the board. Look at the board. Minus 81 is there. Here outside the bracket 12 is there. Please multiply this. So minus 81, it will be 12 times. Did you understand? This 12 is to be multiplied here as well as this term also. Here I write minus 81 12 times. Next. Next, observe. Here minus into minus plus 75 one time is there. Outside the bracket 12 is there. Multiply. It will be 75 12 times. Here I write 75 12 times. Please ask me if you have any doubt. Do you have the doubt in this step?
No, sir.
No, sir.
Okay,
No.
then let's continue. Let us write 237 as it is. Next, observe this carefully. Here, minus 81, 2 times, minus 81, 12 times. Total, how many times minus 81 is
14
there?
times. 14 times.
Very
14
good.
times.
14 times. That should be written. Next, plus 75, 12 times is there. But in the given statement, what we are going to express, there is no 75. Hence, we need to take substitution for 75. Hope that you have understood.
Yes, sir.
Yes, sir.
Sir.
75 into 12. Let us solve 75 from the given statement. Sorry, from the solved statement. It is 237 minus 81. Right. 237 minus 81. Now, this is equal to 237 minus here 81 14 times as it is plus. Now look at the board. Here 12 is there. 12. It should be multiplied with both the terms. 12 into 237. That is 237 12 times. Next. Plus into minus minus 81. Here 12 is there. Multiply 12 with 2. It is
24. 24.
Do you have any doubt?
No,
sir.
sir.
No.
Yes, sir.
Let me continue. This is equal to, observe here, 237 here one time. Okay. 237 one time. Here 237 12 times. Altogether
13 times.
13 times.
237 13 times minus 81. Here
38
14 times. Here 24 times.
sir.
38, sir.
38 times.
8 times.
As it should be expressed in the form 237x plus 81y. So I'll take minus inside the bracket. And this will be plus. Got it? Now,
Sir.
of the form. Of the form 237x plus 81y. So we have answered for second sub question. Then what is the value of m? Sorry, x.
13.
13, sir.
13.
Y
Minus 38.
38.
minus 38. After this, we should find out the value of x square plus y square plus xy square. Substitute the values where x is 13 whole square, y is minus 38 plus x is 13, y is minus 38. You all know that the value of 13 square. 13 square is
169.
169 plus 38 whole square. Let us multiply 38 into 38. 8 is a 64, 6 is a carry, 8 is a 24, it is 30.
1144.
2 is a carry, 3 3 is a 9 plus 2, 11. 4, 4, 4, 1. What is that side?
1044.
Yes, sir.
1444. Here I am. 1444. Plus into minus minus. Now multiply 13 and 38.
Minus 490, sir.
Multiply it. Here 30, 13 8s are. It is 104.
494.
13 3s are 39. 39 plus 10. 40. Have you got same? 494.
Yes, sir. Yes, sir.
Okay. This is equal to. Let us add these two. It will be 4 plus 9, 13, carry 1. 1 plus 4, 5. 5 plus 6, 11, carry 1. 1 plus 4, it is 5. It is 1530. One thousand
613.
613, sir.
minus 494.
Yes, sir.
Subtract this. You'll get 13 minus 4.
1119.
9. Yes. Then here I'll show 1613 minus 494. Here 13 minus 4 is 9. 0 will remain. It becomes 10. 10 minus 9 is 1. 5 will remain. 5 minus 4, 1. Then 1. It is 1119. Have you got same?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Your students, one thing just I'll remind you, and we have noticed that some students will go for using the calculator. Please avoid using calculator because this calculator is not allowed in your final examination. You have to try by practically only. Even our technical department has observed, even some of your parents are given that information also. It is not wise. Okay. Have you got same? 1190.
Yes, sir.
Yes, sir.
Now we are moving to another one. It is also of same type, but a bit different. But this was also given in the examination. That's why I told you, additional problems means all are important. Those will be taken from your previous year question papers and which are also there in different reference books. Right. Fifth one. HCF of HCF of 210 and 55 is expressible in the form 210 5 times plus 55 y full stop 5 y. Dear students, just observe here. Will you go for following the same steps which we followed in the last two problems?
No, sir.
Not necessary. There we followed so because both m and n were unknown, x and y were unknown. But here there is only one term. That is y. Y is unknown. Directly, you have to find out the HCF of these two numbers, either Euclid's division lemma or fundamental theorem of arithmetic. That should be equated to this number. That is 210 plus 55 y. Got it? Hope that you have understood.
Yes, sir.
Okay, right. I told you in this case we have only one variable, and to find out that you can find HCF either by Euclid's division algorithm or fundamental theorem of arithmetic. Anyone can be followed. Here 210 is greater than 55, right? By Euclid's division algorithm. 210 it's equal to 55. How much are?
Plus
45
45.
165. Then how much will remain?
45.
45. 45 is the remainder which is not equal to 0. Continue to divide. Right. 55 is equal to 45 plus 10. Again, remainder is not equal to 0. Start dividing. 45 is equal to 10
is 4 plus 5.
4 plus 5 is the remainder. Then 5 is not equal to 0. 10 can be written as 5
5 to 2 plus 0.
plus remainder 0. As the remainder is 0, HCF will be HCF is how much?
5.
5. Right. Therefore, HCF is 5. And it has been given that HCF of these two numbers is expressible in this form. We can write HCF is equal to 210 into 5 plus 55y according to the given statement. We have found out HCF. That HCF is 5. It is 210 into 5 plus 55y, or else you can multiply it directly. It is 5 is equal to 210 5 0 5
1050, sir.
1050 plus 55y. Transfer that to left hand side. 5 minus 1050, it's equal to 55y. You'll get 1045 minus 1045. Have you got same?
Yes, sir.
Got same.
Sir.
Now transpose 55 to the denominator. This is equal to y. Then y is equal to, cancel it by 5 5 1s are 5 11s are, then here minus 5 2s are 10, 4 is there 0, 9s are. Now y is equal to minus 11 ones are 11.
19, sir.
Y is equal
Minus
to
19, sir.
minus 19. Y equal to minus 19. See, this was given in the examination for 1 mark. For 1 mark, you no need to follow these many steps. Directly, you can identify the HCF and equate that to this statement and find the value of y. You will get minus 9. Now, shall I repeat?
No, sir.
Yes, sir.
Now, 2 types were over. Now, we are moving to the third type. In the third type, we are going to take the problem related to irrationality of numbers. You know that some numbers are proved as irrational numbers by contradictory method. It is the method in which our assumption is a reverse of the given statement. With respect to that, some other statements are there. Let's move on. Right. 6. Prove that root 2 plus root 3 is irrational by contradictory method. Yes, students, you all know that here we have binomial term, right? I have already told you how to take, what steps to be followed when monomial term is there with one as coefficient, when monomial with different coefficients and also binomial are there. Let's go for following the same. Right. Prove by contradictory method. By contradictory method. Let us take root 2 plus root 3 as a rational number. A rational number. You may take that rational number as x, y, even p by q also. X by y, m by n. However, to make the steps easier, I go for taking m. Let root 2 plus root 3 be a rational number m. Then you can write root 2 plus root 3 is equal to m. Followed? Even you may take p by q. If you take single term, it will be easier for solving. Here.
Squaring on both sides.
Don't do squaring on both the sides. The reason is, if you do so, you get root 2 whole square plus root 3 whole square plus 2 into root 2 into root 3. Of course, it can be written as 2 into root 6. Root 6 as irrational. But one thing we know that, what is the product of two irrational numbers? Product of two irrational numbers.
Minus.
What
Irrational
is
number.
the product of two irrational numbers?
Irrational, sir.
Irrational number.
Rational, sir.
Not just irrational.
Rational.
I'll tell you. Yes, it may be rational or irrational. I'll give you an example. Look here. Yeah, root 2 into root 3. Product of these two irrational numbers.
Root 6,
It
sir.
is root 6. Root 6 is also an irrational number. Next, root 12 into root 3. Both are irrationals. Let us multiply them. It will be root 36. 12 3s are 36. Square root of 36 is
6.
6.
Rational.
The product of two irrational numbers may be rational or irrational. Hence, what we will do is we will transfer any one of these two terms to the right hand side. Right. Yes, right with me. Root 3 is equal to m minus root 2. Hope that you have understood.
Yes.
Yes, sir.
Yes, sir.
Now you can go for squaring down both the sides. Then it will be root 3 whole square is equal to m minus root 2 whole square. Root 3 whole square. Square and root get cancelled, you get 3 whole. This is equal to, it is of the form a minus b whole square. It is a square m whole square plus b square. It is root 2 whole square minus 2ab minus 2 into m into root 2. 3 is equal to m square root 2 whole square. Square and root get cancelled.
2, sir.
2 minus multiply this.
Minus 2 root 2 m.
2 root into m. Next, this is, you all know that root 2 is an irrational. So you can go for solving this root 2. Let me transfer this whole term to the left hand side. It is 2 into root 2 into m is equal to m square plus 2 minus 3. Then let us solve root 2. Root 2 is equal to m square 2 minus 3 is minus 1
Minus 1.
divided by 2 root 2. I have written it directly.
2m, sir.
2m. Root 2 is equal to m square minus 1. Remaining 2 into 1, m should be taken to the denominator. Written up.
Yes, sir.
Now look here. You all know that m is a rational number. That's our assumption. Then m square will also be a rational number. We also know that 1 and 2 are rationals. Write the same. m 1 and 2 are rationals. So m square minus 1 whole divided by 2m is a rational. Is a rational. That is equal to root 2. Root 2 is also a rational. Therefore, our assumption is wrong. Hence, root 2 plus root 3 is an irrational number. Therefore, it is proved. One was asking a question.
Sir, you not out, but 2 is a rational number.
Oh, of course. That only we have written. Root 2 is also rational, but correct. We know that root 2 is irrational. Therefore, our assumption is wrong. Hence, it is irrational. Over. Hope that you have copied. Yes. Now, let me go for taking another one. It is also of same type, but in one of the term, coefficient is given. Right. Seventh one. Prove that. Prove that 3 into root 1 plus root 15 is irrational. Let's follow this same step. Right. Prove by contradictory method. By contradictory method. Right. Next, 3 root 12 plus root 15 be a rational. You may assume that rational as m, x, y, whatever it is. Even a also. Let's say a this time. Now, we can write 3 into root 12 is equal to plus root 15 is equal to a. So, any one term, I'll take 3 into root 1 as it is, then a minus root 15. Go for squaring on both the sides. Then, right, it is 3 into root 12 whole square, which is equal to a minus root 15 whole square. Apply square to both the terms. Here 3 square is 9 into root 12 whole square is 12, which is equal to. Now this is again of the form a minus b whole square. Use that identity. A square, a whole square plus b square root 15 whole square minus 2ab minus 2 into a is a only, b is root 15. Now 12 nines are
108.
108. A whole square is a square. Here square and root get cancelled. You get 15 minus. It is 2 into a into root 15. Or else it can also be written as 2 into root 15 into a. We all know that root 15 is an irrational number because we have already come to know that. Let us go for solving root 15. So transfer this term to the left hand side. Minus 2 into root 15a becomes plus 2 into root 15a. This is equal to a square plus 15 as it is. Transfer 108 to the right hand side. It becomes minus 108. Next. It is 2 into root 15a is equal to a square. Subtract 15 in 108.
minus
get-
93.
Yes. Minus 93. Next, solve root 15 only. Root 15 is equal to a square minus 93 by 2a. Hope you have got to say.
Yes.
Now you know. We all know that a is a rational number. It is our assumption. 2 and 93 are also rationals. Then a square minus 93 by 2a is a rational. That is equal to root 15 is a rational. We know that root 15 is irrational. Therefore, our assumption is wrong. Hence, 3 into root 12 plus root 15 is an irrational number. Please do copy that completely. Oh, okay. Now we are moving to some other types of problems.
Sir, explain once again, sir.
Huh?
Sir,
Explain
explain
once
once
again.
again.
Okay. Once I go for explaining, here we have two irrational numbers. Their sum is going to be proved as irrational. We have used contradictory method. According to that, we have assumed that as a. Then that's equal to a. And then we have to solve any one of these two terms. I have solved 3 into root 12. Squaring on both the sides, you will get 9 into 12. Here is of the form a minus b whole square identity. According to that, it has been written. Then 12 9s are 108 is a square. Square and root get cancelled 50. Then this is 2 into root 50 a. You all know that root 15 is irrational. Hence, it should be solved. To solve that, it has been transferred to the left hand side. Then a square 15 are on the right hand side. They are kept as it is. Transfer 108 to the right hand side. It becomes minus 108. Next, a square 15 minus 108 is minus 93. Then solve root 15. Root 15 is equal to a square minus 93. Then 2 into a has been transferred to the denominator. You know that here a is rational, 2 is rational, and also 90. Then this whole term will be rational. That is equal to root 15 is also a rational. But we all know that root 15 is irrational. Therefore, our assumption is wrong. Hence, the given number is irrational. Got it?
Yes, sir.
Okay, I'll rub it. Next, I'll move on to other type problem. And next type is also very important. Even I'm going to take the problem which was given in the examination. It is from S. Chand. Right. It is find the largest number is the 8 one. find the largest number which divides 224, 250 and 302 and leaves the remainder 3 in each case. Leaves the remainder 3 in each case. Copy that completely. Now listen to me carefully. Dear students, just by going through this board statement, you can come to know that whether it belongs to HCF or LCF.
HCF, sir.
Find the largest number which divides all these numbers. The largest number, the highest number from which the given numbers can be divided is HCF. Not LCM, Sudarshan. It is HCF. We are going to find out a number which divides the given number completely. That is highest common factor. Because your attention should be here. Okay. But one thing is, it has been given one more condition that on dividing, in each case, 3 will remain as remainder.
Subtract 3 from each number, sir.
From this, we can understand that in all these numbers, 3 is already extra. Right?
Yes, sir.
Yes, sir.
3 is already a additional number is there. So let us go for subtracting this 3 from each of these numbers. Right? Solution. 3 is remainder in each of the given numbers. Please write with me. Now, it implies that first number is 224. In that 3 is extra, so subtract. You'll get 221. In the next number, we have 250. Subtract. In that also 3 is extra. Subtract it. You'll get 247. Third number is, it is 302. Subtract 3 from that, you'll get, it is 299. Have you got same?
Yes, sir.
Sir. Sir.
Yes, sir.
We want the largest number. So now that largest number will be HCF of these numbers. That is 221, 247 and 290. Here I'll write largest number that is equal to HCF of 221, 247 and 299. These steps are must because we have to mention the remainder which has been given and that should be subtracted. Then we have to give reason why it is HCF. Which concept is to be used in that. That should be written. Largest number is HCF of the given numbers. Okay. To find out the whether you go for Euclid's division algorithm or else fundamental theorem of arithmetic.
Fundamental theorem.
Fundamental theorem of arithmetic.
Here 221 From which number it can be divided?
13.
13, very good. Just by observing only, you can come to know that. Here, 13. 13 ones are 13. You get 9. Then 1, it will be 91. 13 how much are?
7 sir.
7.
7. Yes. Next. Second number is 247. From which number?
3.
3 won't come. Because 9 plus 4, 13. See, one general thing that can be noticed is, observe here, as we are going to find out HCF, obviously, any one of these two factors will be HCF, right? So you may go for trying this by either 13 or 17. Even
13 sir. 13, 19 sir.
13.
very good. 13, how much are?
19 sir.
13 ones are 13. It's
13 twos are, sir, 29. 23, sir.
no. 13 twos are 26.
26 sir.
13 ones are 13. Now 11 will remain. Then 7.
13 9 sir. 170.
13 9s.
Sir, 19 sir. 9 sir. Next, go for another one. 290.
21 sir.
Again,
13
you can
into
go
21.
for 13 sir.
13, 23 sir.
13 twos are 26. 3 will remain 39. 13 3 sir. Now you write 221 is equal to 13 into 7. 247 is equal to 13 into 90. 299 is equal to 13 into 23. HCF. The common factor is 13, least power is 1, therefore HCF is
13.
So conclusion. Therefore, the largest number is, that is, largest number that divides the given numbers, leaving the remainder 3 is 13. Written up?
Yes sir.
Yes, sir.
Okay. So now I'll rub that, and before that, just once we shall cross check it. Look here, you don't go for writing anything. Here we have got the largest number as 13. According to the given statement, if we go on dividing each of these three numbers by 13, what should be the remainder?
3. 3 sir.
3.
Just look here. The first number is 224 and divide this by 30. So it is 13 ones are 13. 12 minus 3 is 9. Carry down 4. Now 13. 7s are
7s are 91.
3 is the remainder. Right. Next, I'll go for taking 250. Just observe 250. Again, start dividing this by 30.
13 9 are 247.
12 carry down 0, 120. You all know that 39s are 117. Again, 3 will remain as remainder. Even for 302 also, you get the same. Hope that this problem was understood.
Yes sir.
Yes, sir.
Yes
Now,
sir.
I'll give you another one, almost of same time. Right. The number is Wait, I'll take from yes. It is only just for practicing. Oh, okay. Right. Find the largest number. Find the largest number. Find the largest number that divides. Find the largest number that divides 628, 3129 and 15,630 to leave remainders 3, 4 and 5 respectively. 3, 4 and 5 respectively. Yes, hope that you have understood this statement, and also you will be able to identify the difference between the previous problem and this problem, because you are not following. Because from Bapuji, should observe, when the teacher is giving the explanation, your attention should be here. Okay, observe. In the previous problem, in each case, the remainder was same, that is 3. But here, we have 3 different remainders, 3, 4 and 5. Once you go through the statement, you are going to find out the largest number that divides the given number, whether it belongs to HCF or LCF.
HCF, sir.
Yes, sir.
HCF. But notice that these are the numbers 628, 3,129 and 15,630 to leave remainders 3, 4 and 5 respectively, which means that when you find out that number, from that number, if you divide 628, you will get 3 as the remainder. If you divide 3,129, you will get 4 as the remainder. Similarly, if you divide 15,630 by that number, you get 5 as the remainder. Got it? Hence, so hi, you only tell.
Yes,
What
sir.
can be written in the first step?
Sir, 3, 4 and 5 are to be subtracted, remainder in each case, sir.
Correct. Next
Then
step.
we should subtract 628 minus 3 and 3,129 minus 4 and 15,630 minus 5.
Very good. You are right. Now, please go for writing the same. Subtract 3 from first number, 4 from second number, 5 from third number. Right. Solution. 3, 4 and 5 are remainder. Just write only this much. Are remainders. Next. Next step. Right. 628. When you divide 628 from the number which is going to be found out, you get 3 as the remainder. Hence, 3 will be extra in that. Therefore, subtract 628 minus 3, it is 625. Next, 3,129 minus 3 is equal to 3,126.
120.
Next,
3,120.
30 minus
3,125, sir.
Sir, that is 3,125, sir.
120.
Minus 4, sir.
minus 4. minus 4, it will be 125, and 15,630 minus 5, it will be 15,625. Next, the largest number is it is HCF of these numbers: 625, 3,125, 15,620. Find out the HCF of these numbers. 625. Go for finding its prime factor. It is 2 5, 25 5.
25 sir.
Next, 3,125. It is 5.
125.
2 5.
125.
125, 25, 5. Next, 15,625. Start dividing this by 5. 5. 3 are 1 are 2 are 5. Again, 5, 625 are 5. 125 are 5. 25 are 5, 5. Right. The prime factorization of each number. 625 is 5 raised to the power 4. 3,125 is 5 raised to the power 5. 15,625 is 1, 2, 3, 4, 5, 6. 5 raised to the power 6. Now, could you tell what is the HCF?
625.
25.
5 raised to the power 4. 5 is common. Least power is 4. It will be 6.
625.
Right. Therefore, the largest number is 620. Over. Now you write. Next, 10th one. Tenth one. Right. Find the smallest number. 5. The smallest number. Which is divisible by which is divisible by 16 and 20. It's a very simple one. It was given in the examination for 1 mark. You are going to find out the smallest number which is divisible by 16 and 20. Now first identify whether this statement belongs to HCF or LCM.
LCM, sir.
Right. Yes, it belongs to LCM. Observe here, you are going to find out the number. Don't think that as it is smallest, it is LCM. Here you are going to find out a number which is divisible by 16 and 20. That means 16 and 20 will divide that number. It is also, we can also understand that that number is a multiple of 16 and 20. Hence, we should find out the LCM of these two numbers.
4, sir.
Right? Right. Solution. So these two, whether these two are dividends or divisors.
Divisor, sir.
Divisors. Right. 16 and 20 are divisors. Next. Smallest number. Smallest number, that is LCM of 16 and 20. Fine. 16. It is 2. 2 8s are, then 2 4s are, 2 2s are. 20. 2 10s are, 2 5s are. This is equal. 16 can be written as 2 raised to the power 4. And 20 can be written as it is 2 raised to the power 2. 2 raised to the power 2 into 5. Now let us write LCM.
80 is the LCM, sir. 80.
You are right. Let us write all the factors 2 and 5. Their highest power of 2 is 4, 5 is 1. 2 raised to the power 4 is 16, 5 raised to the power 1 is 5, 16 5s are 80. Therefore, the smallest number is 8. Right?
Yes, sir.
Okay. Just only we have few problems. Around 5 to 6 problems are there to complete this lesson. And soon after that, I'll go for taking the first lesson in science, that is electricity. So for tomorrow's class, you should get ready with both mathematics and science notes. Do remember.
Thank you, sir.
Okay, shall I conclude the class?
Thank you,
Yes,
sir.
Thank
Sir,
you.
when biology will start, sir?
Yes, sir.
Listen here. What are the problems we have solved today? Please do practice them today itself without fail. And with respect to this, today evening, I'll give you some worksheet questions. Please do practice them. They're
Okay,
all,
sir.
I just go for taking these questions only from your previous year question papers.
Thank you, sir.
So with
Thank you.
this,
Thank you, sir.
thank you very much.
Thank you, sir.